Okay. Can you see the presentation? Oh, okay. Okay, I'll give a short presentation about the modeling value group and especially DClare for MPS. And also you will find similarities with the nice presentation of Ivano, because DClare fills in a part of that generic architecture. So there will be some overlap, but that's a good thing. So DClare for MPS is what it says is DClare integrated in MPS. MPS is a modeling language workbench. And this presentation will only focus on the collaborative part of it. And then within that, the immediate model synchronization between different MPS users. I'm only one user, so the demo will actually be 2 instances of MPS, but they are actually synchronized via a service that could as well be somewhere in the internet. DClare and DClare for MPS is an open source product. Actually, what I'm going to demo is all available, although the demo is still based on a kind of beta, alpha development of the synchronization mechanism. There's no real user interface around it, so you have to set some properties, etc. That's what it is, the functionality underneath, so it works. If you look at the picture that I'm going to present, and here you'll immediately see some similarities, apart from the coloring, is that I will demo 2 MPS clients that both model a model, model X in this kind, and in the demo it will be 2 Sudoku models. And the DClare engine takes care of all kinds of logic on that model, but DClare can also be used for transformations, etc. But there are also plugins into DClare that do the remote connection. Sorry, as you can see here. And then there is a sync service, a DClare stateless sync service, which actually does nothing else than exchanging the mutations between the different clients. So it doesn't have any persistency, doesn't have any logic. It's just a way to broadcast mutations between models. So there can be 3 modelers or 6, and if one creates a mutation, then the 5 others will be acknowledged of that mutation and vice versa. And the prerequisite is that you model a model in the same language. And if you start up, then the models are synchronized in that language. That's the idea. Apart from that, you can also have deferred synchronization via GitHub. I'm not going to demo that because that's not maturized how those 2 completely relate. But the idea is that if you model the same model that is also exchanged via GitHub, then you can also do it in immediate synchronization. And then if you both commit, you will not have any conflicts. Even more, you won't even have a change if you do an update. So that's the idea, that those 2 can be seamlessly combined. That's the idea. Apart from the synchronization, the part that I'm going to demo today, we also have bidirectional transformations in DClare, or any other logic relationship within a model or between models, on whatever level you like. It's a declarative formalism for describing constraints on models, which are automatically ensured. And on the right side, you see how that works from a transformation definition. So you have 2, for example, in MPS, you have 2 meta models in the structure model in MPS, and you can define a transformation in 2 directions between that connects one meta model to the other. And then if you compile that and a modeler models in modeling language X, then automatically modeling the model of modeling language Y will be synchronized and vice versa in 2 directions, and that is also taken care of by the DClare engine, by the plugins. So what we're actually doing is we putting the DClare engine part of your runtime. So in MPS there is a DClare engine running, but there can also be a DClare engine running in an EMF client, and then you can connect them via via the synchronization. And within that environment, you can do all kinds of live transformations between different languages. That's the idea. So if you combine those two pictures, then you get something like this. I could have an EMF client and an MPS client, and they're both modeling a model X in the language of X, or perhaps one I, Y, and one X. But since the transformations are all bidirectional, the whole thing will work together so that you have different services syntaxes or even different languages if they are bidirectional, transformational, and lively synchronized at the same time. So that's the complete picture that we strive for in this project, and we will give demos and keep you informed about developments, but everything is open source available. DClare is actually built on a set of open source projects. We have immutable collection frameworks on top of Java. Then on top of that, we have a DClare engine that is actually kind of reasoning engine, if you like. It's based on the public subscribe logic, so it will just run all the rules until nothing will change anymore and everything agrees. And we have a integration in the DClare for MPS for that, but we also have an easy way to develop DClare-based specifications in Java interfaces, including a integration with Swing, for example, so that you can build completely declaratively defined user interfaces and applications on top of DClare. And we plan for this project also to create a plugin for EMF, and that will imply that we also have interoperability between MPS and EMF, but also that we'll have live transformations, bidirectional transformations within EMF and MPS. So that's our goal, and this is how far we are, more or less. And we'll give a demo now. So it will not take a lot of time. Can you see these two MPS clients? One is white colored, one is black colored. That's just a layout setting of MPS, but it illustrates that there are two different instances, because you can't share that in different ways. These two are already connected. There is a local server running that exchanges JSON messages with differences. And in this case, those differences also contain the actual identities which are used by MPS to persist the models, which also implies that if you exchange those objects, that the persistency via the Git will not run into conflicts. There can be different solutions for that. We're also working on one which is based on structural identity, more or less a kind of pattern matching that you can also use for different technologies. But then, of course, you will have different models. And if you persist them in Git, then you can't merge them or something like that, because it's a different kind of model. So this is a simple Sudoku example. You can actually set the size of the Sudoku. All the logic of the Sudoku is driven by DClare and the DClare for MPS plugin. Also the nice layout of the table, etc., which is out of the box not well supported in MPS, is supported by DClare for MPS, so that you have ways of coloring and keep it consistent. Well, I can see actually what the different values are. So it already has logic underneath, you see that, which are possibly to fill in. So if I put a 4 here, then you will see that I have two red places because I can't put 4 here. I put another nice little bit Sudoku. But you also see the other side synchronized with a little bit of ugly coloring, because that's the default of MPS. The same logic runs on the right side. However, everything that is not persistent is not exchanged by the synchronization mechanism, because it doesn't make any sense, because the same engine runs on the right side. So only the real model parts, what we call the structural, which come from the structural specification of MPS, instances of those parts that are also persistent in the Git are are interchanged between those two clients. So it's not really. So I can also create, of course, a good solution, and then you see on the left side that everything becomes green because then it's correct. But you can also see that I can just change on either side, and it will be synchronized in live. I can also create, for example, a new Sudoku game, give it a name, and this is the Sudoku which has a slightly more size, and then you can see that here the Sudoku is also created. For example, I can also remove the Sudoku if I want, delete it. And then the Sudoku on the left side is also deleted. So it also accounts for models that are synchronized. What we plan for is more functionality on different angles. And also Ivano has pointed out some of those functionalities. We want to have more control on the collaboration. So who is modeling which models, and also which models in my project are collaborated with others. And we talk about so-called rooms where you can meet and where you can share a model as persons. And also we want to provide functionality, just like in Google Docs, where you can actually see in the editor where the focus is of the other user, with the name of the user, with pop-ups. Because now it becomes a complete surprise who is going to fill in which numbers in the Sudoku. And it would be nice if you can see where the other user is looking at. And you see in Google Docs that works quite nice. So that's very important functionality. So that will also be a kind of meta information that is exchanged, but we're working on that. It's not provided yet. So this is actually it. It's actually currently it's driven by a simple setting here. It says, well, you need to connect synchronization via this local, via a website and a port. And the other side also, if that's the case and you start up MPS, then you will automatically have connection. But of course, you want to have more control, because if you have partly models that you do not want to share and partly models that you want to share, you want to change the settings and choose via which server or via which room on a functional level, which models are to be synchronized with other users. So that asks for an extra model and user interface to orchestrate that. But that's currently not the functionality that it's in this prototype. So, short presentation, short demo. Any questions?
Renaud has one, I guess.
Yes, I raised the hand because I need to leave in 5 minutes, so I want to be sure that I could ask. Wim, one thing is the LSP and the GLSP protocols, they already have some information about what we call user awareness. So like where the cursor of the other users is, or which elements are selected. So you might give a look at least at how they are representing this information in their own protocol. Yeah,
perfect. Yeah.
Then I have another question related to so here we are within MPS. So I was thinking about how does this change when we start talking about MPS and EMF collaboration?
Yeah, well, it depends. Of course, you need something like a Sudoku in EMF. So what we are planning is to kind of exporting a MPS model into an EMF model, and then you can either create a service syntax on that EMF eCore model, meta model in EMF, or you can create a transformation between an existing language and that eCore model using DClare bidirectional transformation. Either will work, and then you just need to have the DClare plugin in your EMF Eclipse environment and in your MPS environment. However, there is something which is very important here, and I already addressed that, and that's the identity. The beast is always the identity in these kind of issues, because if I create a Sudoku and another one creates a Sudoku and you're going to synchronize, how do you know that you have the same Sudoku or a different Sudoku? Because this is within one technology, and this solution uses a way of exchanging the standard identity that is used within NPS projects, so that they know that they mean the same thing. However, EMF and NPS do not share a common notion of persistent identity, unique identity of nodes. So, or you have to create that, or, and that's what we are proposing and which we're actually developing, is to have a structural relationship between it. So, for example, if you create a model with the same name, if you say the name is unique for a model, then those two models will be synchronized. And since you have a number of rows and columns here, you also know uniquely which cell relates to which other cell. So it's not based on a implicit identity, which is persistent, UUID or something, but a structural identity based on your language, and you can actually set what you want to be identifying in your language, so that it will be exchanged cross technology. So that's the second flavor, and if we have developed that flavor, which also will work in MPS, by the way, so even projects we do not share the same Git but still have the same language, you can actually synchronize the models there in that other strategy. So those two things together will enable EMF, MPS synchronization, or any other technology for that matter.
This is interesting, because in the architecture that I was discussing before, I tried to generalize a bit from the concept of identity.
Yeah.
Meaning that I know that we need to have a shared identity across elements, across models. What I did is I defined an extension point called identity resolver. And then you can have your own, heuristics for matching elements across different models, like ID-based, name-based, structure-based, or your own.
Yeah.
So
okay.
I think we are very much aligned. This is
yeah, that will be completely compatible.
Yeah, indeed.
Yeah.
This is good, very good.
Yeah.
Thank you, Wim. Guys, I need to leave. Sorry, because I have another meeting and I need to walk to the meeting. So thanks. I will leave the word to. I will leave you to the meeting, and I will ask Oscar for an update.
Yeah, sure.
Bye, Ivana.
Bye. Bye. I stop recording now. See you.
Any other questions?